We're solving problem 11 from the 2026 AIME 1. The integers from 1 to 64 are placed in some order into an 8x8 grid of cells with one number in each cell. Let A sub I, comma j be the number that is placed in the cell in row I in column j, and let m be the sum of the absolute differences between adjacent cells. So this formula up here. Find the remainder when the maximum possible value of m is divided by 1000. Note that in an 8x8 grid, there are 36 interior cells, 24 edge cells, and 4 corner cells. Now, the number 32.5 holds significance in this problem because it is the middle from the values 1 and 64. So, that means that two adjacent cells, the maximum difference or maximum value of the difference is simply the difference between the sum of the differences between the two numbers from 32.5. So we have this formula right here that represents our current situation here. Now, what we want to do is we want to put the numbers that are closest to 32.5 on the outside, and then the next closer ones on the edge cells, and then finally the ones that are furthest away from 32.5 on the interior to maximize our sum of m. Thus, we have the 36 interior cells, which will be an 18-18 split between the lower echelon of the numbers from 32.5 and the higher echelon of numbers from 32.5. So we then have 1 all the way to 18, and we do 46 and 46 to 64, because 46 plus 18 is 64. This is for the interior, and we can then start to find our sum. So our sum is going to be 2 times the sum of k equals 1 to 18, and we multiply by 2 because we're adding it 2 times. So what we can do is we do 32.5 minus a. This gives us 828. And what we can do after is, so for the interior cells, there are 4 adjacents. So we multiply this number by 4. So 828 times 4 is equal to 3,312. Our next numbers will be our 24 edge cells, where it is split into 12 numbers in the lower half and 12 numbers in the higher half. So we will have 19 to 30, 19 to 30, and we have, what is that, 35? Yeah, 35 to 46. We can then do the sum thing over again, so 2 times the sum from k is 19 to 30, and then we do 32.5 minus a, and this yields us 192. So we want to multiply that by 4 again. And then we have, shoot, I did that wrong. And then we finally just have these 4 corner cells, which are going to be the numbers left over. So we have 31, 32, 33, and 34. Now the distances between 32.5 are respectively 1.5 plus, and we'll just sum them to make this process quicker. 1.5 plus 0.5 plus 0.5 plus 0.5. No. The last one's 1.5. 1.5. This is So this is 1 plus 3 is 4. So then we multiply this by 2 to get 8 because there are 2 adjacents for this one. And then, there's 2 adjacents. So then we have now a sum where we just want these three numbers. We have 192. We still have to multiply that one, but 192 times 3. So then 3312 plus 192 times 3 plus 8. All this basically just evens out because we just want to calculate mod 1000. So any digits from 1000 and beyond don't matter. So therefore, when we just do mod 1000, our answer will be 896 for this problem, and we are done.